have been asked previously, or which are good question but not asked, but there is a possibility that it can be asked. So let's begin with our some questions. If you have any doubt, you can ask. Any doubt, write in the chat box. Any doubt, any question, previous question, any concept, you can write here. Any concept. So let us attempt this question. What it is telling? It is telling that a capacitor is charged the battery U, okay, and another capacitor of the same capacity is connected with it in parallel with the first capacitor. Then the energy stored in each capacitor will be. So let us see. It is given that the capacitor is having a charge U. Let its capacitance be C. Okay, it is charged up to U. Now let assume it is connected to a battery of V voltage. That means U is equal to half CV, like this. Now it is telling that one answer also came. Okay. Good. All of you are attempting good, very good. Now let us check. Now it is telling that after some time, what happened? We disconnected it. We disconnected this capacitor and we connected a parallel to it a one capacitor of the same capacity. Remember, this is having some charge, some potential, and it is connected to the same capacitor. Okay, now both are in parallel connection and they will have same potential. Let it be a V. From here, we know if it is U is equal to this, we can also write it half QV, like this. Okay, now if they are connected in parallel combination, their equivalent will be what? It will be 2C. Now we can say that U, to calculate U, we need half C V1 square or Q square by 2C, like this. Okay, now let us see. If initially, let us see if initially it was having a charge Q, okay, charge Q and U as potential. We know that initial charge was Q. That means it was having U is equal to half QV. That means Q was equal to 2U by V, like this. Okay, same charge was present here. Charge got distributed, and we know since both are same capacitance, that means it will attain charge of Q by 2, and here charge will be Q by 2. Okay, now let us move here. We know the new capacitance for each capacitor, how much energy will store is equal to Q square. That means new charge will be half by 2C. 2 into C is new capacitance is 2C. We can write like this. It will be Q square by 4 into 4C. Okay, we can write like this. You can see. Okay. I think okay, good. Yes. I think 1 2 factor extra factor came. So from somewhere, I think one extra factor came somewhere. You can see. Let us erase something. Let us see. I think here. Now, let us see. Okay. Initially, it was having capacitance C. Okay. Capacitance C, energy was U is equal to half CV square. Now it is connected like this. What we are getting? We are getting U is equal to 2C. Now here, what we will do? We can see that. It is here. We will see that when they are connected like this, we know initial potential, initial charge, that was Q, will be equal to, we know by charge conservation also, U will be equal to, I'm using another method because I got here something lengthy. That's why it's using second method. By charge conservation, we know initial charge was Q. Okay, it will be equal to, we know that it will be equal to CV, and it can be equal to total capacitance here 2C into new potential will be V. We can write like this. So from here, V will be Q by 2C, like this. We got new potential. Now we are using here Now we are using here like this. U is equal to half C V square, like this. You can write like this, half, okay, C, half C is 2C, and V square is equal to Q by 2C whole square. You can write like this, okay. You will get Q square by 4C, and we know that Q square by 2 into 2C, we can write like this, and we know this is the value of initial energy U. That means new energy stored will be U is equal to U by 2. Okay, so our answer will be A. Any problem here or any calculation mistake done here? You can see once more. Any problem to anyone? Initially I took some lengthy method, that's why I taken using charge conservation method, okay. But through this method also we can solve the question, no problem. All method we can use, okay. This method I used because it was I got it very fastly through this method, okay. Any method to any problem to anyone? Any problem to anyone? All of you please interact. We will have very much interactive session today, okay. All of you please interact, all of you please interact. I will be waiting for your response. Now let us see this question. I give you 30-second time. All of you try this, all of you try this. I give you 30-second time. All of you try this. All of you try this. I give you 30-second time. All of you try this. Try this, all of you. Any answer? Any answer came? Any answer? You have to just count the number of capacitors. Answer is B. Okay. Let me see. So here, one answer came B. Okay, let me see. We know that we see here that 4 points we are connected through P. It is not given which is positive, which is negative. Okay, no matter. Here we can, if we assume this as positive and this as negative, we can say it is positive plate, it is positive plate, it is positive, and it is positive. This one is negative plate, this one is negative plate, and this one is negative plate. Now let us count the capacitor first. How much capacitor is formed here? You can see first. Count the capacitance. You can see here it is first capacitance. You can see here we are having some capacitance. Let us count. Here one capacitance C1. You can count here one capacitance C1. Second capacitance here C2. Third capacitance here C3. You see I am taking positive and negative plate. Third capacitance, fourth capacitance C4, fifth capacitance C5, and sixth capacitance C6. We see that we are having 6 capacitor and all are in parallel connection. You can see all positive plates are connected one side and all negative plates are connected one side. So 6 capacitance all connected in parallel combination. All connected in parallel combination. We know all connected in parallel combination, if each are having value C, we know their equivalent will be 6C. That means 6 into capacitance of one capacitor, epsilon naught A by D. So our answer will be this. That is, I think one person has given correct answer. Good. Any problem to anyone? Any problem to anyone? Any problem? Please interact. Any problem to anyone? Okay, good. All of you should interact. Okay, now let's move further. Now, give you 10-second time and you should answer the question. Decide your answer. Take 10-second time. 10-second time. Answer this question. 10-second time. Take 10-second time and answer this question. Any answer? Waiting for your answer. Any answer? Any answer? Any answer? Any answer to this question? Any answer? Okay, let us see them. It is telling that we are having two metal spheres, one of A, and it's given that B has greater radius than as compared to A. So let us assume we have one radius A and one sphere like this having B. Okay, and it is telling that both are having a charge of 100 microcoulomb. So it is having a charge of 100 microcoulomb, and we know if it is having same charges but radius is less, so here surface charge density will be more as compared to this one. It is having more radius. So what will happen when we will telling that it is telling that they are and they are connected by a conducting wire, and it's telling that they both are connected by a conducting wire like this. What will happen? Charge from high density will travel to low density. Yes, good. Now also charge from high density will go to low density. Or we know that since A has low radius, that means C will be, suppose it is having C and it is having C2. We know that C2 will be greater than C1. That we know. From here also we can write, but it is best concept that here charge density is more. So charge will flow from high density to low density till they have same potential and the density. Okay, what will happen? Charge will flow from A to B. Any problem to anyone? If you will ask more, I will answer more. Otherwise, I will answer only the theory part which are required. But if you will ask more, I will answer more. Any doubt to anyone? Please interact. Any doubt? Interact. Anyone? Any doubt? Any doubt? You can interact. Explain again. Okay. That's good. Okay. Sir, once more. Yes, once more. Okay. Let us see once more. Let us see it once more. Okay. Now, it is telling that, let us see, it is telling that we are having two metal sphere. Always remember, we are having two metal sphere. It is having another metal sphere like this. It is having high radius, greater radius as compared to first one. Okay, and is given that B is greater than A. Suppose they are having same charges. They are having same charge. Charges are same, but so we know that both will have, but the A will have more charge density because its radius is less, and we have studied earlier also charge density is inversely proportional to radius of curvature. That's why we studied that at the tip of the object having less radius, there will be a more charge density and leakage occurs from here. We have studied in our theoretical part also. So here there will also a charge, but charge density will be less. So by this way, you can tell it that charge will flow from high density to low density. One thing. Secondly, by formula also you can tell, you know that if they are having same charges, let us suppose they are having same charges. Let us suppose they are having same charges. Let me tell you, if they are having same charges, Q and Q, same charge, it is given in question, and we know that there is capacitance C1 and C2, and we know that C2 will be greater than C1 because we have studied that C is equal to 4 pi epsilon naught R. If R is more, C will be more. C2 will be greater than C1, and we know that Q is equal to CV. That means V is equal to Q by C. Now see, here for C2 capacitance, for second capacitance, you can see for second capacitor, you can see V is equal to Q by C2, and C2 is more, so its potential will be less. But for first, what we can say, we will see that for this capacitor, we will see that for this capacitor, we will see that what V is equal to Q by C1, and C1 is less as compared to C1 as C2, so its potential will be high, and it will have high potential and it will have low potential. Okay, so when we connect both of them, charge will flow from high potential to low potential by this way, or we can say by high density to low density. Okay, now any problem to anyone? Clear? All of you doubt clear? All of you doubts clear now? All of you doubts clear? Okay, now let's move further. This is a question. Try. All of you try this. This type of question, this question has been asked in your NEET exam. Many times it is asked, this type of question. I give you 30-second time. All of you take it like a test and try. All of you try this question. All of you try this question. Last class I have given one shortcut also. You can use that also. Try. All of you try. All of you try this. All of you try this. All of you try this. Any answer? Any answer? Anyone? Anyone? Any answer? One answer came, option C. Okay, let me try. Okay, one answer came. Okay. Yesterday we have studied one shortcut, I think. What I told you? I told you if we are having capacitor C, if I cut it like this, we have 2C capacitance and 2C capacitance, and both are in series combination. I have told you in last class. You remember? And second shortcut, what like this? If we cut the capacitor like this in equal half, then it becomes C by 2 in parallel. Okay, such that its equivalent will be C and also its equivalent will be C. Okay, that was the concept we have studied, and that is a shortcut also. So if you can see here, if we actually it is not clear, the terminals, two terminals not drawn clearly. So let us assume these are the two terminals. Let us assume. I think that pass and missed here. Now we can see here, if it was originally having capacitance C, let us assume it was originally having capacitance C. When we cut it from here, then we know that when we cut it like this, we know capacitance will be C by 2 and C by 2 for here. Okay, C by 2 for here and C by 2. Then we have cut it like this. That means C by 2 into 2, C by 2 into 2, like this. Okay, now we can say like this, if because this was the capacitor in vacuum. Okay, now they are filled with the capacitor dielectric K. So multiply this by dielectric constant 6, multiply this by dielectric constant 3, multiply this by dielectric constant 6. What will be the equivalent capacitance? Two capacitor here in series and parallel to it. We know these two capacitor, what it will be? 3C, and here it will be 6C. We know two capacitor 3C and 2C in series. We know 3C is series with 6C, and we know it will be 3C into 2C and sum of both of them 9C. Like this we can solve like this. We will get 2 by 3. Please check the calculation part. Usually I make some mistake. Now, this capacitor is in parallel with upper capacitor, that is 3C. So we know that 3C a capacitor is parallel to 2 by 3 capacitance. That means it resultant will be 3C plus 2C by 3. It will get what we will get? We will get 9C plus 2. We can write 11C by 3. Okay. Okay now what we can write? I think some calculation mistake has been done. Somewhere something mistake have been done. You can see, we have to check, and we know if we fill this capacitor by single capacitance, we will get capacitance of C into K like this. Then what we will do? We will equate this Kc is equal to 11 by 3C, and we can calculate the value of K. But I think some calculation mistake done. Maybe some calculation mistake done here, I think, or it can be okay. Yes, I think some calculation mistake have been done, or it can be the terminal can be on this side also. The question is not mentioning that, but step is this one. This is the best step to attempt this type of question. It is very fast and you can solve it very nicely. Okay. Okay, got it. Anyone has any problem? If you are knowing that concept, you can apply. Okay, or should I solve it? Anyone? You can solve it, or I should solve it here. You got the concept how to attempt this question? Please answer, please interact. Should I solve it, or you will try? I have taught you the concept here only. Okay. Should I solve it? I think I have to solve it. No one interacting. Why? Oh, let me see what is mistake have been done here. Let me see what mistake done here. What mistake I have done here? Let me see. Okay, let me see. Upper capacitance, we know we have cut it here like this. It will be we know C by 2. Okay, C by 2 here, C by 2. Okay, C by 2 3C, and the lower part we know it will be C by 2, C by 2 and C by 2, C by 2, C by 2. Okay, I think this was the mistake here. Oh yes, it was 6C. 6C. And it will be like this. Solve here. It will be, I think, 2C. That's what the mistake. 2C. That only not 2C. Now we will do here like this. 3C and 2C parallel to each other. What we will get? We will get here. C is equal to what? 5C. C equivalent is equal to 5C. Then what we will do? Then we will replace here Kc is equal to 5C, and we will get K is equal to 5. Okay, that was the mistake, and answer will be 5. Any problem to anyone, or should I solve it once more and by clearing all the pages? Anyone, any problem? You have to know this question because this type of question usually comes in your exam, and similar question have been I have taken in, I think one question, and you have to solve it. Anyone, any problem? If confused, then please tell me. I will explain it once more. Anyone, any problem? Okay. Nice. Anyone, any other? Please interact, all of you. Okay. I think no one interacting, but you should interact. Okay, let's move further then. Let us see this question. I'll give you 30-second time and you try this. You have to try. All of you try this. All of you have to try this. Try this question. All of you try this question. Answer came. Answer came. Tell me what answer came. Answer came. Tell me what answer came. Please tell me what answer came. Anyone, any answer? Okay, let us see that. It is given that a capacitor C1 is charged to V volt, then uncharged capacitor. Okay, it is very simple. I think this type of theory we have discussed earlier also. C1 capacitance is connected to V volt. You remember previously question I have discussed this type of question now. What we know, it will get a charge with a positive Q, and the positive Q will be, okay, one answer came, option C. Let me see. Plus Q, what we know, it will be C1 into V. Okay. Okay. Then it is connected to uncharged capacitor C2. It means that this C2 is connected with, okay, like this. C1 here, C2 here. We know they will get equal potential here. Initial charge is C1B. Okay. Final charge. We know, let us assume final voltage will be V dash. We can say total charge on C1 will be Q1 is equal to C1 V dash, and on charge C2 capacitance will be C2 into V dash. So initial charge, by charge conservation we can write like this: C1V is equal to C1 V dash plus C2 V dash, and V dash will be C1 V by C1 plus C2. Okay, any problem? And you can take the answer also. Any problem to anyone? Any problem? Any problem to anyone? Oh, Nandini got C. How she got C? Any problem? Any problem? Please tell anyone. Please interact. Any problem to anyone, or should I explain once more? Any problem to anyone? Please interact here. Please make this session interactive. Otherwise, I will also feel bored and I will not able to teach you with a potential. Okay. Anyone, any problem? All are silent. Why? Okay. Okay. Please interact. And all of you, like I think Afia, Barika, Nandini, as all of you should interact. Okay. As much as you will interact, I will be more comfortable, and I will give you more good concept. Okay. Okay, let us see what. Okay, good. All of you, good. Good response. Very much interest. Okay, good. Take next question. Okay. Now, take this question. Try all of you this question. Try all of you. Try all of you this question. I think this type of question you can do now. I have taken this type of question many times also. Okay. All of you will try this question. Take it as a homework. Take this question as your homework. All of you have to try this. Okay. All of you have to try this. Will you try, all of you? Because I don't want that some of the important questions should missed. You have to try this easy question. Okay. This type of question we have. You can use charge conservation, or you can write some of the potential difference like this. You can write the potential like this. Also, you should try. If you get any problem, you can ask me in tomorrow's class also. Okay, all of you will try now. Please interact. I need spirit of you all. You should have some spirit. Yeah. Yeah, that's a spirit of a doctor. Yeah, good, good. That's a spirit. Very good. You have to be some spirit so that you will become a doctor then. Okay. Let us see. Move this question. I give you 10-second time. This is not a very much good question, but you should try. Take 10-second time and try. Take it like your exam. I think this is a new type of question. That's why you should try. Try, all of you try this. All of you try this question. Option D. What you get? Work done in charging both the condenser. How much work done is the work is done in charging both the condenser? This is the question. Okay. Now you have to do this question. I tell you few more things. Work done by battery to charge a capacitor is equal to Q is equal to Q into V. This is the formula. What is the work done in charging a battery? This much work is done by a battery. Or we can write like this, CV square, like this. Second, I'm telling you the formula. You have to use this formula and solve the question. Also, energy stored in capacitor, okay, it is half of QV is equal to half of CV square, or you can write like this, Q square by 2C, and here you can write like this, Q square by C. What we see, suppose a battery is doing a work of 10 joule, then capacitor get charged, energy stored in capacitor, is what? How much? 50%. 10 joule work is done by a battery and 5 joule energy is stored in capacitor. That means 50% energy is lost. 50% loss occurs, and this loss occurs in the form of heat and other forms of energy. Okay. Use the theory and you can solve the question. Okay, all of you can solve this question now. This was the concept. All of you, please tell. All of you try it now. All of you try this now. Yes. Good. Using this concept, you can solve the question, because I think if I will do all of the question, then you will get nothing. So for some of the question, I will give you the theory part, some concept, and rest part you have to do it and find the answer. Okay, all question if I will do now, then you will get nothing. Okay, now let us see further. Okay, all of you try this question. This question for all of you. I will not help in this question. You have to do, all of you have to try this question. I will not move my pen a single bit also for this question. You have to discuss this question by your own. All of you take 30-second time. All of you try this. All of you. Any answer came? What you have to do? You have to take, it is given that it is having a capacitance in vacuum. What you will do when we are cutting like this? What we will get? We will get C by 2 here and C by cutting like this now. Then we will get 2C here and 2C here. Okay, 2C again cut in 3 parts. We know it will be divided by 3. That means here will be 2C by 3, 2C by 3 and 2C by 3. Any problem to anyone? Okay. And use this method also. Same method. These three are in parallel and they are in series with this. Multiply their K1 here, K2 here, K3 here, K4 here, and then compare with this. Kc is equal to, put all this way and find the value of K. Confused? All of you confused? Confused, all of you? All of you got confused? Confused. Okay, confused. Okay, let me tell you that. If you got confused, then let me tell you. Let me tell you. Let me tell you. If you got confused, then let me tell you. Let me tell you. We know when we cut the capacitor like this, we will get 2C capacitance here and 2C capacitance here. Okay, 2C capacitance here, they are cutting here like this. You can see here, they are cutting here like this. One part, second part, and third part. So when we are cutting like this, 2C in 3 part, here will be 2C by 3, 2C by 3, 2C by 3. Such that if we take equivalent of this, we will get a capacitance of C. You can check also. 2C by 3, 2C by 3 and 2C by 3 in series. You can check like this. You can check like this. 2C by 3, 2C by 3 and 2C by 3 in series, and it is parallel to 2C. If you will take equivalent, you will get C. Okay, this is the method of cutting. Okay, now in the question it is telling that we are filling with dielectric. Any problem to anyone till here? Till here, any problem? Till here, any problem? Any problem till here? Okay, now let me see what we are do. It is 2C by 3. We multiply here with K1. Let me change the color of ink. Let me multiply K1 here and K2 here and K3 here and K4 here. That means it will become K1 multiply here, K2 multiply here, K3 multiply here and K4 multiply here. All in series. What we will do, we will add. That means C take common and we will get C by 3 common, 2C by 3 common. What we will get? We will get K1 plus K2 plus K3. We are adding, okay. Series combination na. These three are series in a series combination na. What we will do for series combination? We know for series combination, we know for series combination, these three are in series combination, this one, this one, this one. We know their equivalent will be 1 by C equivalent will be opposite of this. What it will be? It will be 3 by 2 K1C plus 3 by 2 K2C plus 3 by 2 K3C. Okay. We know 3 by 2C will be common. We can write C equivalent is equal to 3 by 2C common. That means 1 by K1 plus 1 by K2 plus 1 by K3 like this. Okay. This is C equivalent of these three series one. Okay. It is in parallel with 2C. Then from here we can write like this. Here now from here we can write like this. From here we can write like this. C equivalent is equal to C equivalent is equal to what we can write? We are writing like this: 2C by 3 into K1 K2 K3 by K1 K2 K2 K3 and K3 K1. Okay, this C equivalent, let us say C equivalent 1. This C equivalent 1, it is parallel to 2C. So final C equivalent will be 2C by 3, that is K1 K2 K1 K2 plus K2 K3 plus K3 K1 by I think mistake now. I think it is here K1. So mistake is doing more. Okay, now K1 K2 K3 by K1 K2 plus K2 K3 plus K3 K1. This is in series in parallel with 2C. So add up to C here. It will be C equivalent, and this C equivalent will be equal to K into C. Okay. Now cancel C both sides. Take common and cancel the C. You solve this, you will get the value of K, and you can match your option from here. Okay. Any problem to anyone? Any problem? Okay, okay. And one more thing. Here it is K4. Okay. And I think you are getting the answer like this. You can see here. I am seeing the answer. You can see the answer. You will get match your answer from here, and your answer will be, you can see here, your answer will be, I think D. I think it will be D, but you have to match. You have to check it. Okay. Any problem to anyone, or should I solve it once more? Okay. All of you, please write like this. Doubt, no doubt, like this. Okay. I get confused after that. Okay. So let us move further, and let us see this question. So take 10-second time and solve this question, all of you. Take 10-second time and solve this question. Take 10-second time, all of you. Take 10-second time. Take 10-second time, all of you. Take 10-second time. Try your own. Got answer? Remember, this is the force between the capacitor plate. You should remember this formula. Okay. F is equal to Q by A epsilon naught. This is for parallel plate capacitor. Okay. Now we know this, and also we know that C is equal to epsilon naught A by D. That means epsilon naught A is equal to C into D. This we know. So, or also we know that Q is equal to CV. Why I am putting like this? Because I am seeing the option there in terms of CV and D. So we can write the force like this, Q like this. Q is equal to CV and 2 epsilon naught A like this from CD. Right, like this, C into D. You can see F is equal to, I think, Q square. Formula is F is equal to Q square. That means it is C square V square. You can solve it like this. What you will get, you can write, put it, try of your own. All of you try your own. Try this, all of you. Try this. You should remember this formula. This formula you all have to remember, all of you. Okay. Now try this question, all of you. What will the answer option match? Match your option. Okay. If you got your answer, okay. Now let's move further. Then. Okay, now let's move further then. Okay, this is a good question. asked in your exam. So answer this. Good question. Answer this question. Answer this question. Answer this. Anyone? Any answer? Any answer? Any answer? Okay. Let us. Let us. We know one thing. We know one thing. We know that we are having electric field E here in air, and then we know it get. Okay. Okay. Tell me what is your answer? Option C. Option C. I think it can be, but we have to see it. Okay. Let us see what will be the answer. So we know for an electric field, we know for an electric field, that inside the dielectric it becomes what? E by K1 here, again in air E, again here E by K2, and again here E. We have seen that here it is getting decreased. So if we want to plot here according to like this, what we will do? What we will do? We will plot like this. Okay. We will be plotting like this using this equation. What we will do? We will do that here. First it is C, first it is E. After that it is getting decreased because E by K will be less. So E by K here, it is becomes E by K1, and we know that K2 is greater. So after this again it is becomes a like this same. Now K2 is more greater. That means E by K2. K2 is more greater. That means it will decrease more. That means here it will decrease more like this, and again it will become E. Now you can match your answer, and I think your answer was correct. C, I think, was correct. Okay, answer C was correct. Okay, good. Okay, now, so let's move further. Okay, let us move further. Try this question. I think this is the easy question. You must have studied in your class 10th also. Try this question, or you will try. I give you for your homework. Okay, you will try. What you will do? What you will do? Yes, what you will do? You will cut the ladder from here. Okay, and assume here C equivalent, and C equivalent here, and take here also C equivalent this side, and solve it, and you can find your C equivalent. Okay, I think you can solve. So I will not waste the time here. Let's move further. Try this question. Try this question. I think this is, I will give you 10 seconds. This type of question, this theory we have discussed earlier. You take 10-second time and discuss. Try this. Okay. I think it was okay. So I will not explain this question. I know you have done. So let's move to this question. Try this question. These are good set of questions. You should try. I give you 10-second time, 15-second time. Try this question. All of you try this question. Try, all of you. Try this question. These are good set of questions. Try this. All of you try this question. Try this question, all of you. Any answer? Any answer? Any answer? Any answer? So let us see. Let us see. No problem. You are not getting the answer, then no problem. See, what we have to do? We have to find the potential at O. Let the potential at O is, look at it very clearly. Let the potential at O is V. What we will do? We will use like this. We will say like this. We will say that the charge, we can say like this. We can say like this. The charge flowing from here and the charge flowing from here will go down this side. We can say like that. Suppose it is having charge flowing Q1 from here, Q2 from here, then charge Q3 will be like this, and we can say Q3 will be equal to Q1 plus Q2. Now, if we want to write Q3, how we will write? We know Q is equal to CV. So Q3 we can write like this. Q3 we can write like this. Here it is capacitance is 7C into V is V, and here it is 0. V minus 0. That means we will say V potential difference is equal to, for Q1 we can write like this. It is 10, and here it is potential is V. So for Q1 we will write like this. C is 1 into V is 10 minus V plus, from here it is having potential 2 into CV. V will be 4 minus 0, 4 minus V, 4 minus V. So what it will be? 7V. You solve this. Solve this, all of you. What answer came? Any answer? Any answer came? Any answer came? Anyone? Anyone? I think 3. That will be 4. It will be 8. Okay. Answer is option D, 1.8. Okay. Okay. I think approximate answer, na? Approximate answer getting. Okay. Accurate. See, any calculation mistake is there? We are writing here Q3. Q3 will be voltage V minus 0. We know Q is equal to CV. Then we are writing as C and V. Q 10 volt 7 into V minus 10 plus 1 into 10 minus V plus, okay. Yes. That's good. That good. I know. This is my calculation mistake part. Yes. V is equal to thank you. Yes. It will be, here will be 10 volt is equal to 18. V will be 1.8. Good now. Explain. Any problem to anyone? I know. Usually I make some calculation mistake. I know. Usually, that's why I told you. Be careful with me, because usually I make some mistake. Okay. Now let's move further. See this question. Try. All of you try this question. It is very good set of good question. Try this question. Try this question. All of you. Try this question. We have to find the capacitance between A and B. Try this question. All of you try this question. Take 10-second time. Try this. It is telling that what will be the equivalent capacity between A and B. How to find the equality? Let me tell you one shortcut. How you have to find. Okay, if you are now knowing your shortcut, it's good. I tell you one shortcut. Let us assume this will be potential having VA. It will be having a potential of, okay, option B answer came. Okay, let us see. Potential VA, and here will be potential VB. Okay, we can say here this one and this one is in parallel combination, and this one and this one in parallel combination, and also this one and this one. Okay. Should I explain or you have solved it? Should I explain or you have solved? Please tell, you have solved or should I explain it? Okay, good. Let me tell you. These two capacitors, they are in parallel. I have drawn here. They are meeting at a point A. You can see. Let us assume this point as a D. This meeting point is D here. After that, from D, we are having one branch here and one branch here and one branch here. All are meeting at B. From D, we are having three capacitors, one here, and one here. All are meeting at same point, that is B. Okay, one capacitor left this one. What it is? It is from A to B direct. We can say that one capacitor is like this, A to B. You have to find the equivalent of this and you will get the answer. Any problem in drawing this equivalent capacitor, equivalent circuit? Any problem? How I have drawn this? Should I explain it once more or you have got it? You can find the equivalent of this. Okay. I tell you once. That's why I was telling that. Write clearly. Explain yes, no. I usually get confused. What is the meaning of yes? For what you are telling yes or no? Okay. Now let us see. If it is having a potential VA, and let us assume it is having a potential of VB, we can say this potential will be VA. Let us assume this point is D. You see, between A and D, how many capacitors are there? You can see there is one capacitor, this one capacitor, this one. So look this capacitor. Its one terminal is at here only connected to VA and other terminal is connected to D. You will say that between A and D, there are two capacitors. So connected parallel. I have drawn here, you can see between A and D, two capacitors. Now they are meeting at point D. From D, we can see there are one capacitor like this one, and from this one we can see both are having, all are having same point D. It is also having the same point D, and it is also having the same point D. Though all are connected directly, not any capacitor or resistance are present between them. So this and this, they all are connected to D directly. So from D, three capacitors, and they are connected. Its other end is connected to B, its other end is connected to B, and its other end is also connected to B. So from D, three capacitor, this one, one in connected to D, other in connected to B, one into D, other to B, one into D, other into B. Okay, now this capacitor left, this one, you can see it's one end is connected to A and other is connected to B. There is no capacitor in between there. So we will say this capacitor is between A and D. So between A and D directly. Okay, I have drawn this. You take the solve it, take parallel combination, then series, you will get the answer. Okay. Any problem? Got it. Okay, good. I think you can do it. This question is very simple. I think you will do it. You can do it. Okay. Okay. Take 10-second time, 5-second time. You can do it. I think I will do it. Okay. Yes, you can do it. I think you can do it. These are basic questions, so we should not waste our time here. Do this question. Try this question. Try this question. All of you try this question. Try this question. Take your time. Try this question. All of you try this question. Try this. Try this question. Any answer? Any answer? Any answer from anyone? Now let us see. Let us see. No problem. Let us see. It is telling that each are having capacitance C. You have to find the ratio of capacitance between P and R. The ratio of capacitance between P and R here, and between P and Q here. So if we want to know, we want to calculate between P and R, we will see these are in series and these are in parallel. So between P and R, we will write C equivalent is equal to series C in series C by 3 plus C by 2. They both are in series. We can write like this. It will be directly 6. That means 5C by 6. Between P and C. Now, between P and R was not earlier. Now, between P and Q, you can see between P and Q. You can see if we are talking about P and C, we will see that here we can see that this one, this one, this one, this one, all 4 are in series and 1 parallel. So 4 in series, we can write like this. C equivalent is equal to 4 in series. We can write C by 4 plus 1 parallel C. So it will be how much? It will be 5C by 4. Now we have to take the ratio. We have to take the ratio of both of them. What it will be? We can write 5 by 5, 6 by C. Take the ratio. It will be 5 by 5, 4 by, 4 by 5C. 5C by 6, 5C by 6 and 4 by 5. You will solve it and you will get the answer. Okay, I think some mistake has been done anyway. Any mistake I have done anyway. Got it the concept, or I should solve it once more? You can solve it or I should solve it. Check anywhere calculation mistake I must have done. You can see between P and R, between P and R here. You can see 1, 2, 3, both are in series. So we write C by 3 and they will be in series C by 2 and both are in parallel. So C by 3 plus C by 2. We will get 6 and we can write 5C by 6. Now between P and Q here. You can write like this. C. All 4 are in series combination. We can write like this. It will be C by 4 plus 1 parallel C. We will get here 5C by 4. And the answer will be 5C by 6 into 4 by 5C. I think some typing mistake may have occurred. Okay. Must be some mistake in option also. Maybe some during typing mistake have been done, but this will the answer. If I have done all things correct here, then it will the answer only. Okay, this is the concept only. Okay, to solve this type of question, so don't worry about it. Okay, so solve this question. I know you can do it. This type of question you can do it. This type of question you can do it now. How you will do? I will give you one trick also. How you have to do it? What you will do? You will write here potential as Vp. Here also Vp. Okay. Here potential you write V1. Then here will be V1. Here V1. Here will be V1. Okay. And then solve it. From Vp we have connected like this. From Vp draw like this. Think draw like this. From P we are connected through one capacitor. Take like this. Here V and point like this V1. Then take point like this here. Draw here Vp, here V1, and you take here last point as VQ like this. Now between Vp and V1 there is one Vp and V1. You draw here between Vp and V1. Draw say. Now you go here, come here. Vp and V1. Again one capacitor. Again draw this. This one done. Now Vp and here V1. See this also. One more parallel. This one also done. Now V1 to here V1. Okay. Coming here V1. V1 to VQ. There is one capacitance. V1 to VQ. There is one capacitance. V1 to VQ. Here you can see there is one capacitance. Here it is V1, it is one capacitance, and it is also telling that here it is V1, here it is also V1. You see that for these two capacitors, they are having one terminal connected to V1, okay, and this terminal is connected. So they both are in series parallel combination. We can say like this, okay. What we will do? We will take two capacitors like this. Both are having a potential of V1. Okay. Let me draw this like this. Like this. They both are connected like this. You can see here. Yes, they both are connected like this. Both are connected like this here, and from here they are connected from V1. We are having one capacitor C here. Okay. Any problem to anyone? Any problem? You can try this. Any problem in drawing this? Any type of capacitor, you take this attempt and you can draw. Any problem to anyone in drawing this circuit? Any problem? Okay. You have to proceed like this one. Okay. If you get any problem, you can ask. Now, read this question. Take 10-second time. Read this question. 10-second time. Oh, I think this question is the similar type of question that we have done earlier. Okay, we have to find the potential at point P. Let it be a B. Okay. Try this question. Okay. Now, what it is telling, it is giving us a hint also. What it is telling? It is telling that charge here stored will be equal to charge here stored. So we can write here Q will be, this Q will be C1 into V will be V1 minus B for this capacitor. Now for this one, we can write like this: Q is equal to C2 into V minus V2. Now, since the charges are same, you can equate both of them and find the value of V. Okay. Solve now. You can solve with this now. Solve this now. I think you can get the answer from here. Value of V. Please respond. Please respond. Yes. Good. So let's move further. This similar type of question we have done earlier also. You can see you have to find the number of capacitor, calculate the capacitor, how much capacitor you are forming, and you can solve like this. Okay. Okay, this is your homework. You go through a session and then you can solve this question also. Okay. Yes. Yes. You go to a session and now for this question, the potential at P. How you will do this? You know the potential will be V here. Both are all are in series. You know if they are in series, what will happen? The charges will be same. Here, charges will be same. Assume here Q, here Q, here Q. You know this Q will be CV, this Q will be CV. You are not knowing the potential of here, but we are knowing the potential here is 0. That we are knowing. Let us assume this potential like this, V1. And you have to find this potential only, V. You can write expression for here. What you will write? Q is equal to C. 3 into 11 minus V is equal to 1 into V minus V1 is equal to 2 into V1 minus 0. Solve this equation and you will get the value of V, and V will be your answer. Got it? Any problem? Any problem? Any problem? Tell me, please tell. Okay, nice. So solve this and get your answer. Okay. These are similar type of question. These are homework. We have studied earlier also. Two sphere having radius, different radius. Okay, when we will switch on high density to low density, or we can say that from high potential to low potential we flow. Okay, till both get same potential. Okay, charge will flow from high potential to low potential till both get same potential, V here and V here. Okay, you can solve it. Okay, you can solve it, or I should solve it. And one more thing, don't feel shy. Actually, I tell you to solve this question. If you feel that it can't be solved by you, feel free to say that you can't solve or any problem. Okay, I usually tell because I think that yes, good, that's the spirit. Good, good. And if you get any problem, then before starting the session of tomorrow, you should tell me that question number. Write this question number and tell me what it was the question number. I will see this question and explain that. Okay? Yes. You only tell me the question number. Now, that is the same thing we have discussed earlier. Okay? This question also same thing we have discussed earlier also. Find equivalent between A and B. How we will do? These three are in series and it will be parallel to this. You can solve this question. Okay? You can solve this question. Okay, now. Yes. Good. Now, let's see this question. See this question. I will tell you this question. It is having, we are having 12 capacitors. This is a good question. This type of question usually comes in current electricity chapter also. 12 capacitance. We are having 12 capacitors. Okay. How to take attempt of this question? We are having time. 12 question. 12 capacitor. How we will solve it? Now, Let us assume that if we are having flowing some charge Q, what it is telling that find between A and B, how much capacitance will be there. You have to find the capacitance between A and B. So what we will do, we'll take here point A and B, which assume that here charge will be Q by 3, here charge will be Q by 3, here charge flow will be Q by 3. Q by 3 go here, then again separated, here one capacitance more, here will be Q by 6, Q by 6, here Q by 3 distributed again, Q by 6, Q by 6, again distributed Q by 6, Q by 6 coming from this side. Okay, what we will get, Q by 6 from here and Q by 6 from downward. We will get here Q by 3, Q by 6 from here, Q by 6 from here, we will get Q by 3 here. Q by 6 from here, Q by 6 from here, we will get Q by 3 here. So across A and B, what we will get? We will get 3 capacitor like this, parallel, then 6 capacitor like this, all parallel, then again 3 capacitor like this. This is the combination. Okay, you will solve and you get the answer. Remember one thing, one trick I give you, one short note point. For any cube having capacitor, remember one point, between horizontally opposite side, between this and this. Suppose we are having A and D. Capacitance across A and D is always equal to 6C by 5. Now, we take another point. Let me take A and here. A and assume here C. Oh, let me change the color. A and this point is C. Opposite but on the same phase. Then capacitance across A and C, it is gives 4C by 3. Okay. Now, if we try to find third, remember this. And I also explained how we can get, I will explain here. Now, if we have one point here and one point is here, let us see. This point is A, B, C, D. Assume here B. We can say capacitance, I change the pen here. Okay, it will be capacitance across A and B. It will be 12C by 7. Remember these 3. Okay, and directly you can use your capacitance. Okay, for a cube arrangement of a capacitor. Okay. Okay, now, and I have also told you how you can solve between A and B here, diagonally opposite on the opposite face. Okay, got it? Yes. You can try this question. I think you can try. You can do it. Okay, you can do this question. Solve this question. Okay. Remember one thing. In solving this question, what you have to remember, this capacitor C2 will be useless. No use. Because parallel to it, we are having a connecting wire like this. So it will become useless and it will be equivalent to 2 capacitor, one here and connected like this. It is C. So answer will be 2C direct. This will become useless. Okay. So let us move this question. I think this is also an easy question. Oh, AB not given now. Let us assume A here and B here. You can solve it parallel, and then both series series, and then 3 are in parallel. Okay, you can solve this type of question also. Take a screenshot. You should try this question. Okay. Okay now. Yes. This question. This question. You only try this question. What you will do? You assume here B point. Here is A point. Here it is also A point. Okay. Connected to what? We can draw like this. A here and B here. Okay, between A and B, you can see A and B, there is one capacitance C. So I draw here C. Now, between A and B, there are 3 capacitors in series. So between A and B, 3 capacitor in series. Now, just solve it and get the answer. Okay. Okay, now. These I think simple setup question. Okay. Yes. This also same type of question which we have done. Type the count the capacitance C1 and C2, and both will be in parallel. You can solve it. Okay. Okay now. So these are last question. So you should try this. Okay. Tomorrow we will be starting new chapter. Okay. If tomorrow class is scheduled, then we should discuss with Ganesh sir. Now, I will discuss now. You do try all these questions. This will be very much beneficial for exam. And after this, you should try some more questions from your practice set or previous year paper like this. And you should try few more questions also. Then you will get confidence in it. Okay. So keep your study going on. Good night and take care.